All right, here's a video for notes 9-3, tests about proportions. So I have a claim that I make 80% of my shots, but you suspect that I'm exaggerating. In an SRS of 50 shots, I made 36. Does this data provide good evidence that I'm exaggerating my claim that I make 80% of my shots? So in step one, we're going to identify N, P, and P hat. So this problem is about proportions because I'm given a percent, as well as the fact that whether or not I make the shots is categorical, which is why we're dealing with proportions. So my SRS is going to be 50, or my sample size is 50. P is what we're going to assume to be true. We're assuming that I make 80% of my shots, and then P hat is my sample proportion, and that's going to be 36 over 50, which is 0.72. All right, in step two, we're going to write out our hypotheses. So we know this is a one sample proportion problem. So it's going to be P is equal to 80%. So we're assuming that to be true. And our alternative hypothesis, evidence that I'm exaggerating my claim, meaning I probably make 80% of my shots, where P represents a proportion of shots Miss Okita makes. In terms of conditions, these are the conditions that we check for proportions. These should feel pretty familiar because they're the same conditions that we checked in Unit 7 as well as Unit 8. One thing to point out, though, in Unit 8, we use P hat here because we were given P, we were estimating P. But in this problem, since we have a value of P that we're assuming to be true, that's what we're going to use in our normal condition. All right, so let's check the conditions for our problem. So our independent condition is that big N, which we have a sample of 50 shots, so big N is going to be all shots, is greater than or equal to 10 times 50. So it is reasonable to assume that the number of shots that I've taken at a basketball hoop is greater than or equal to 500. So that's reasonable to assume. For the normal condition, we're going to do N times P, so 50 times 0.8, which is going to be 40. That's greater than or equal to 10, so that's good. And I'm going to do 50 times 1 minus 0.8, which is 10, and that's greater than or equal to 10 as well, so we would say that it's approximately normal. And lastly, for the random condition, it does say SRS, so we would say SRS is stated. So our three conditions are met. All right, so in terms of step 4, this is where we do our calculations. So in our calculations, we need two things. We need our test statistic and our p-value. So generally, the test statistic is calculated by doing the estimate minus the hypothesized value divided by the standard deviation of the estimate. More specifically for proportions, it's going to be p hat minus p over the square root of p times 1 minus p over n. So this p sub 0 is the value of P specified in the null hypothesis, which in this case is 0.80. Once we have our test statistic, we're going to use that value to find our p-value. In terms of finding the p-value, we look at our alternative hypothesis. If our alternative hypothesis says greater than, we look at our table and subtract that value from 1, or look at the opposite side. If it says less than, we just look at the table value and use that. And then if it says not equal to, we look at the less than value, and then double that. All right, so now let's do our calculations here. So to get our test statistic, we're going to do p hat, which is 0.72 minus 0.80 over square root of 0.80 minus 1 minus 0.80 over n, which is 50. So let's put that in our calculator. So on top, it's 0.72 minus 0.80, and on the bottom, square root, and then a fraction, 0.8, 1 minus 0.8, all over 50. We get negative 1.41. So this is my test statistic, that's Z. And now we're going to find the p-value. So remember that our alternative hypothesis had a less than symbol. So this means that we're going to try to find the probability that Z is less than negative 1.41, which using our rules that we learned in Unit 2, that means we're just going to look up negative 1.41. And that's the value, that's our p-value. So 0.0793. All right, so lastly, conclusion in context. So I'm just going to say this verbally. Since our p-value is 0.0793, it's greater than alpha, we fail to reject our null hypothesis. We do not have enough evidence to conclude that the proportion of shots that Ms. Okita makes is less than 80%. So when we fail to reject, we say we don't have enough evidence for our alternative hypothesis. Okay, just a little bit of practice finding p-values. So again, p-values based off of two things, your test statistic and your alternative hypothesis. So in this case, we would just look up negative 1.89 in our table and take that value for what it is. We get a p-value of 0.0294. And in this case, if alpha is 0.05, we would reject our null hypothesis. When it's greater than, we look up this number and subtract from 1, or look at the negative side. When you do that, you should get 0.0287. If our alpha is 0.01, since this is above alpha, we would fail to reject our null hypothesis. And then lastly, if it's not equal to, what we're going to do is we're going to look up 1.75 on the negative side. So 1.75 on the negative side, which is this, and we would double that, which gives you 0.0802. So if you were to look up 1.75 and try and double that, you would get a value greater than 1. So you would know that you did something wrong. So remember, you look at the negative side and double it. All right, so here's another example. So I'm not going to read it. I'm just going to start kind of identifying things. So n in this case is our sample size. That's 100. P is what we're believing to be true. That's our parameter. It says 75%, so 0.75. P hat, we have 68 out of 100 say that work stress has a negative impact on their life. So that's 68 out of 100, which is 0.68. All right, in terms of our hypotheses, again, this is a one sample proportion problem. So P is equal to 0.75. And our alternative, since it says differs, that just means not equal to 0.75. Where P represents the proportion of people who think that work stress has a negative impact on their personal life. So instead of writing it down, I'm just going to say it verbally again. P equals the proportion of people who believe that work stress has a negative impact on their personal life. In terms of the conditions, big N in this case is going to be all employees at the restaurant. It's greater than or equal to 10 times 100. 10 times 100 is 1,000. It is reasonable to assume that there's more than 1,000 employees at this restaurant, considering it's a large restaurant chain. So I'm going to say reasonable to assume. So that's good. The normal condition, we're going to do N times P. So 100 times point, remember we're using P, 0.75, which is 75. That's obviously greater than or equal to 10. And then 100 times 1 minus 0.75, which is 25. That's also greater than or equal to 10. So that's good. So we know that we're approximately normal. And then for the random condition, it does say a random sample. So that is stated. All right, for the calculations, we're doing the test statistic and the p-value. So remember that p hat was 0.68 minus 0.75 over the square root of 0.75 times 1 minus 0.75 over 100. So in our calculator here, I'm just going to change these values. So 0.8. Five over 100. That gives me a test statistic of negative 1.62. And since our alternative hypothesis says not equal to, that means I'm going to look up the negative value and double it. So look up negative 1.67. Oops, on the negative side. Negative 1.6. This is 0.0475. And when I double that, I get 0.1052. So there's my p-value. So lastly, conclusion in context. Remember that our null and alternative hypothesis said, or my alternative said differs. So since our p-value is greater than alpha, so since our p-value is 0.1072 is greater than alpha of 0.05, we fail to reject our null hypothesis. We do not have enough evidence to conclude that the proportion of employees at this large restaurant chain feel that work stress has a negative impact on their personal life differs from the national average.